Namaste and a very good morning to all of you. I welcome you to my channel, The Outlier. My name is Mithun. In today's video, I'll be talking about the 1992 US Presidential Election Survey Data Analysis. Even before I proceed to demonstrate how to carry out analysis on this particular data, may I request you to subscribe to my channel, also like and share my videos. In this data set, I've got 6 columns. The first column represents the age of the respondent. Second column is the age category. The third column represents education level of each and every respondent. The fourth column represents the degree that the respondent has obtained. The next column would be gender of the respondent. I've got 5 columns representing the demographic details of the respondent. The last column here represents the preferred presidential candidate. We have 3 presidential candidates. Let me quickly apply a filter on this particular column. Who are the 3 presidential candidates? You can see here, the first candidate would be Bush. The second candidate would be Bill Clinton. And the third candidate would be Perot. We are interested in identifying the profile of the respondents and their choice of the presidential candidate. Let me click on the cancel button here. Let me interpret the first record for you. The first record belongs to a respondent whose age is 79 years. The age category that he belongs to would be 65 plus. The education level would be 12 years. The degree would be high school. His gender is male, and his preferred presidential candidate would be Bill Clinton. The one question that I'd like to ask at this stage is, what is the sample size in this data? Let me go to the last record to show you the sample size. As you can see here, 1850. So we have approximately 1,850 records in this data. 1,850 is a good sample size for us to carry out any analysis. With this background about the data set, let me now proceed to SPSS, wherein I will be carrying out the exploratory data analysis. Also, we'll be looking at how to build a predictive model in this data set. As you can see here, this is the SPSS software. You can see the name of the data set. It is called as voter.sav. These are some of the columns that you saw in the spreadsheet. I've already loaded this particular data set in SPSS. In the first stage, I will be carrying out exploratory data analysis. Since most of the variables in my data set are categorical, I will be using what is called as the cross tabulation procedure. To carry out cross tabulation of the demographic details with that of the preferred presidential candidate, you can go to the Analyze menu bar. The second option from the top would be descriptive statistics. Here, I'll choose the fourth option from the top, which is called as cross tabulation. This option is very useful when you have a lot of categorical variables in the data set. Let me go ahead and select this particular option. As you can see, this opens up a new dialog box, which is called as the cross tabulation dialog box. In the canvas to the left-hand side, you have the 6 variables. SPSS expects me to specify the variables along the row and another variable along the column. I'm going to choose the demographic details of the respondents along the row. The last variable, namely the preferred presidential candidate, would be chosen along the column. I can go ahead and hit the OK button. This will only give me a simple cross tabulation between each and every variable in the row with that of the column. If you want to specify additional options, like a chart or chi-square test, you have to make more selections. At the left-hand side bottom corner, you have an option which says display clustered bar chart. Let me go ahead and select this particular button which says display clustered bar chart. The second thing which I'd like to show you is the working of the statistics tab. Let me go ahead and select the statistics tab. This will produce the cross tabulation statistics option. Right at the top, you can see the chi-square option. You may ask me, what is chi-square? Chi-square is a test of association. It tests whether there is a relationship between the variable along the row and the variable along the column. Let me click on continue. Now, let me proceed to select cells. SPSS displays a lot of options here. By default, SPSS produces only the absolute count. Along with the count, I'd like to see the row percentages as well, and hence I'd like to select row percentages here. Let me hit the continue button. With these selections, you're all set to carry out exploratory data analysis. Let me now hit the OK button. What you're seeing now is the output window in which SPSS generates the different output. Let me draw your attention to the bar chart. Now, this bar chart is one of the 4 bar charts that SPSS has generated. Along the x-axis, you can see age category and the 4 different age categories here. That is less than 35, 35 to 44, 45 to 64, and 65 plus. You can see here in the legend section, the blue color represents the preferred candidate being Bush. The green color bars represent Perot and the brown color bar represents Clinton. When we look at the 45 to 64 age bracket, the tallest bar here is the brown color bar, and brown color bar represents the people who have voted for Clinton, which means that when the age category of respondents is 45 to 64, majority of them have preferred Clinton. But we should not be surprised, because when you look at some of the other age categories as well, the preferred candidate seems to be Bill Clinton. Now, should we take these results seriously, or is it due to some accident of fate? There could be a mistake while sampling. There could be sampling bias. We could have taken a wrong sample. To further add solidity to our analysis, let me proceed to show you the cross-tabulation results. You can see here, age category is broken down by the different age groups. SPSS displays the count along with the percentage within the age category. When you take a sum along the row, it adds up to 100%. Along the column, you can see the vote for either Clinton, Bush, or Perot. I'd like to draw your attention to the chi-square test here. SPSS reports 3 important measures. The first one is Pearson's chi-square. The second one is likelihood ratio test. And the third one is linear by linear association. The second column here reports the value. For example, the Pearson's chi-square value here is 56.5. The degrees of freedom is 6, and the p-value is 0.000. SPSS reveals that the column heading here is asymptotic significance value. You can either call this as asymptotic significance value or simply the p-value or the probability value. How do we interpret the p-value? There is a simple thumb rule. If the p-value is less than 0.05, which is the level of significance, you reject the null hypothesis and conclude that there is a relationship between age and the preferred presidential candidate. And if the p-value is bigger than 0.05, you can go ahead and conclude that there is no relationship between the two categorical variables. Clearly, you see that the p-value of 0.000 is less than 0.05, and therefore I'll go ahead and reject my null hypothesis and conclude that there is a relationship between age of the respondent and the preferred presidential candidate. Let's now proceed to look at the second bar chart. The second bar chart is a bar chart which shows the relationship between highest year of school completed by the respondents and the preferred presidential candidate. As you can see here, there are a lot of categories starting from 3 all the way up to 20. Let me draw your attention to those respondents who have completed 12 years of school. The tallest bar here represents the brown bar, and you can see in the legend section, the brown bar represents a vote for Bill Clinton. So what is the conclusion that we can draw from this analysis? We can state that when a respondent has completed 12 years of education, the preferred candidate, presidential candidate, is Clinton. Here again, consistently I see the brown color bar dominating some of the other bars, indicating that irrespective of what is the highest year of school completed, Bill Clinton seems to be the preferred candidate. Let's now proceed to look at the chi-square test. SPSS reports the Pearson's chi-square value as 71.9 with the degrees of freedom as 34. The p-value here is 0.000. The value of 0.000 is clearly less than 0.05. Since it is less than 0.05, I can go ahead and reject my null hypothesis and conclude that there is a relationship between the two variables. That is, the variable highest year of school completed has a relationship with the preferred presidential candidate. Now, one of the questions which people ask is, how do I remember whether to reject or accept based on the p-value? There is a simple statement that you can keep in your mind, which goes as follows. When p is low, null will go. I repeat, when p is low, null will go. On the other hand, when p is high, null will fly, implying when p-value is low, you need to reject your null hypothesis. On the other hand, when the p-value is high, you need to accept your null hypothesis. Let's proceed to look at the third set of data analysis that we have carried out. Here, we will be looking at the highest degree obtained by the candidate. There are different levels here, like less than high school or high school, junior college, bachelor, or graduate. Let me draw your attention to those respondents who have completed their high school. Clearly, the tallest bar here is pointing to Bill Clinton, implying that when the respondents have completed high school, the preferred presidential candidate is Bill Clinton. We've seen three variables so far. It clearly seems to me that the favorite candidate, irrespective of the age bracket or the highest year of school completed or the highest degree obtained, is Bill Clinton. The last of the variables that I will be analyzing. But before I proceed to the last of the variable, let me check the chi-square test for highest degree and the preferred presidential candidate. You can have a look at the Pearson's chi-square value of 35.5. The degrees of freedom is 8, and the p-value here is 0.000, indicating that there is a relationship between the highest degree completed and the preferred presidential candidate. With this, I will now proceed to show you the fourth variable that I have chosen for analysis, which is the variable gender. Along the x-axis, you can see male and female. Very interestingly, you can see that the height of the blue bar is on par with the height of the brown color bar. However, the brown color bar slightly outperforms the blue colored bar. What does this indicate? The blue colored bar represents those people who have voted for Bush, which means that when the respondent's gender is male, approximately 50% of them have voted for Bush. The other 50% of the male candidates have voted for Clinton. What happens when the respondent's gender is female? Clearly, you can see there's a very tall bar for Clinton, which means that women candidates prefer Bill Clinton. Is there a relationship? Is there a scientific reason as to why this is happening? Or is this just happening by chance? The answer for this question will be given by the chi-square test. Let me draw your attention to the chi-square table. You can see here the Pearson's chi-square value is being shown. The value is 33.8. The degrees of freedom is 2, and the p-value is 0.000, which is very less. And therefore, I can go ahead and say that there is a relationship between the respondent's gender and the preferred presidential candidate. So we have carried out the chi-square test for 4 demographic variables, namely age, highest year of schooling, the highest degree obtained, and the respondent's gender. All the 4 variables are related. With this, we conclude the exploratory data analysis. Let me now show you multivariate analysis. I'll be showing you a technique which is called as decision tree analysis. How do you carry out the decision tree analysis? To carry out the decision tree analysis, we can go to the Analyze menu bar. From the Analyze menu bar, you can move to Classify option. Here, SPSS displays 6 different options. Let me go ahead and select the 4th option from the top. The 4th option from the top is what is called as the tree diagram. Let me select this particular option. As you can see, this generates the decision tree dialog box. For those of you who are very new to decision tree, let me draw your attention to 5 important points about decision tree. What is a decision tree? A decision tree is a graphical representation of the relationship between the independent variables and the dependent variable. The first important point that you need to keep in mind while building a decision tree is that it is a supervised machine learning technique. I repeat, it is a supervised machine learning technique, which means we have to specify a dependent variable here. The second important point that you need to keep in mind is that it's a non-parametric approach towards model building, which means here we are not concerned about the distribution of the dependent variable. The third important point that we need to be concerned about when we are building a decision tree model is that it can handle mixed data type. I repeat, it can handle mixed data type, which means you can have a categorical dependent variable or a scale dependent variable. Similarly, you can have categorical variables as your independent variables or scale independent variables. Number 4, you would require very less time for data cleaning procedure because a decision tree model can handle noisy data. Last but not the least, a decision tree model is very simple and easy to interpret. One major disadvantage of the decision tree model is that it is highly susceptible to the problem of overfitting. With this background about decision tree model, let me proceed to specify the dependent variable and the independent variable. As I've already mentioned, the most important variable in this data is the preferred presidential candidate. What is the profile of those respondents who vote for Clinton vis-a-vis Bush or Perot? The last variable will be pushed into the dependent variables list. The rest of the variables will be taken as independent variables. This will give you a basic decision tree. I'd like to draw your attention to the growing method, which is CHAID. CHAID stands for chi-square automatic interaction detection. This is very useful, especially when the dependent variable is categorical. Let me click on the drop-down menu. Here you have three other options. The second option is called as exhaustive CHAID, which is again a flavor of the CHAID algorithm itself. The next option that you have is the CART model. CART stands for classification and regression tree. The last of the options that you have is what is called as QUEST. QUEST stands for quick, unbiased estimated statistical tree. You can choose any of these four options for the data that we are working on. I will go with the default option of CHAID algorithm. I would like to save the predicted probability for this data. How do I save this? As you can see, there is an option called as Save button. Let me go ahead and select the Save button. This will show me the save options under the decision tree. I can go ahead and save the terminal node number, the predicted value, and the predicted probabilities. I will be saving the predicted value as well as the predicted probabilities, and I'll go ahead and hit the continue button. With these selections, we are ready to generate the decision tree model on our dataset. Let me go ahead and click on the OK button. You can see here, SPSS quickly generates the decision tree output. Though SPSS prints a lot of tables, it is beyond the scope of this video to explain some of the other options. I will straight away take you to the tree diagram. This tree diagram, as you can see, is not very clear. Let me double click on the tree diagram. When I double click, you can see what is called as the tree editor window. Currently, the percentage is 100. Let me click on the drop-down menu and increase it to 200%. Now, the visibility and the clarity of the graph is high. As you can see, this is the output of the decision tree. The output of the decision tree resembles a org chart. Typically, in any organization, you can see the CEO right at the top. Then you may have the president and the vice president. Further, you can have the managers, assistant managers, and the employees. The same way, you can see a box right at the top. This box is called as the parent node. This gives us the distribution of the dependent variable. In the dependent variable, 35% of the candidates, 35% of the respondents have voted for Bush, 15% of the respondents have voted for Perot, and approximately 50% have voted for Clinton. Right below the dependent variable, you can see a vertical line which is pointing out to age category, which means age is identified as the most important variable to classify a respondent as a Bush supporter or a Clinton supporter. You may ask me, on what basis has the algorithm chosen age category? The answer is chi-square statistic. What the algorithm has done is it has identified the chi-square value between the independent variable and the dependent variable. Higher the chi-square value, greater is the association. The highest chi-square value between the dependent and the independent variable is for the variable age category, and therefore age category is chosen to be the best predictor to classify a respondent as a Clinton supporter or a Bush supporter. You can have a look at the p-value, which is 0.000 less than 0.05. So this variable is a significant predictor in determining whether or not a person would vote for Bush, Perot, or Clinton. Let me scroll down to the extreme left side. You can see the distribution of the respondents when their age category is 65 plus. So essentially, we are talking about older respondents. When we look at the behavior of older respondents, clearly the preferred candidate is Bill Clinton. Approximately 58% of those respondents whose age is greater than 65 years plus have favored Bill Clinton. This is called as a terminal node because there is no other node below this particular node. Let me now draw your attention to the box next to this particular box. Here you can see the distribution of age category. Either it is less than 35 years or anywhere between 35 and 44. Now, what is the behavior of respondents who belong to this particular age category? When the respondent's age is either less than 35 or between 35 and 44, the majority of the respondents have preferred Bill Clinton. Approximately 44% of these respondents have preferred Clinton. But hang on, I cannot make a decision based on this node alone because this is not the terminal node. I have to look at the next criteria, which is respondent's age. So after age category, what do we have? Respondent's gender is the second best parameter. You can see here to the left side, we have the distribution for male, and to the right side, you have the distribution of female. For male respondents, the majority of the respondents have preferred George Bush. You can see here, approximately 39% of people have preferred George Bush, which is very close to that of those people who have preferred Bill Clinton. What happens when the gender of the respondents is female? Clearly, 50% of them have preferred Bill Clinton. As you can see here, this is how easy and simple it is to interpret a decision tree model. Some of the alternatives to decision tree model are either a logistic regression model or a discriminant analysis model. You can also go ahead and use what is called a support vector machine. However, these algorithms which I mentioned just now are highly complicated and slightly technical in nature. This is why people prefer to use decision tree because it is simple and quite effective. It's very easy to understand. Let me interpret the last set of nodes here. When the age category of the respondents is anywhere between 45 and 64, you can have a look at the distribution. Majority of the respondents have preferred Bill Clinton. Let me scroll down and look at respondents' gender, which is the second best predictor. When the age category is from 45 to 64 and the gender is male, 42% of them have preferred Clinton. On the other hand, for female respondents, approximately 60% of them have preferred Clinton. So this is how SPSS helps us identify the different profile of respondents and their voting pattern. One question that might come to your mind is this model accurate? Should I take it seriously or not? I'll answer this question in a bit. Before answering this question, I'd like to show you a couple of options here. At the left-hand side, you can see the orientation. The current orientation of the decision tree is top-down. You can see here, you have the dependent variable, and below the dependent variable, you have the different categories of the independent variable. You can change the orientation of this particular graph from left to right by clicking on the option that is available. You can have a look at this. Now the graph is shown from left to right. The interpretation does not change. However, the layout of the graph, the orientation of the graph is changed. You can also change the orientation from right to left. This is also very, very interesting. It's mostly useful when you want to look from right to left. You can see here to the extreme right, you have the distribution of the dependent variable. Then you have to move from right to left to identify some of the terminal nodes. I'll go back to the original graph, which is a top-down approach. There are another couple of options which I'd like to show you. The default settings will only show you the table in the tree nodes. You can see the distribution of the respondents in each of the categories. However, if you want to show the graph instead of the actual numbers, you can click on the option show charts in the tree nodes. You can see here the distribution now represents a graph. You have a nice little bar chart which shows the preferred presidential candidate. If you want to show both tables and as well as graphs, you can choose the option, the third option, which is show tables and graphs in the tree node. At the top, you can see the numerical display, and here in the second half, you can see the graphical display of the distribution of the respondents and their preferred presidential candidate. This is only for display purpose. This does not change the analysis. I'm happy to go back to my original layout. This is the original layout. Now, do we trust this output or not? To answer this question, let me first of all close the tree editor window. We will have to look at what is called as risk. Risk is a very, very important statistic. This tells me the probability of misclassification. As you can see here, low risk represents a good model. On the other hand, if there is a high value of risk, it means that there are more chances of the model misclassifying an individual. That is the problem. In our case, it is 0.50, which means there is a 50% chance of us misclassifying a respondent, which is on the higher side. Therefore, we need to take the results of the decision tree model with a pinch of salt. Let's now look at the output of the classification table. This is also called as a confusion matrix. Along the row, you can see the observed category, and along the column, you can see the predicted category. Predicted by whom? Predicted by the decision tree model that we have built just now. The diagonal elements here represent the correct classification. For example, 148 Bush supporters have been correctly predicted by the decision tree model. Similarly, when you look at this number 0, this is a dangerous number because none of the Perot supporters have been correctly predicted by the decision tree model. This is a cause of worry. Let me now focus on 768, which means that 768 Clinton supporters have been correctly classified. The last column is the percentage correct column. What does this indicate? This indicates the percentage of correct classification for each of the candidates. So when identifying Bush supporters, our model is accurate 22% of the times. When we are trying to identify Perot supporters, the model is accurate 0%, which is quite dangerous. Lastly, when it comes to identifying Clinton supporters, our model is accurate to the extent of 85%. The overall percentage of accuracy in this model is less than 50%. It is barely 49.6%, which is a clear indication that this model from a statistical standpoint is not a good model. Had the overall percentage of correct classification been in excess of 70%, then we could have taken the results of the decision tree more seriously. However, we are not interested in building an accurate model because this model has been built only for academic reasons, only for a learning purpose. Let me now proceed to show you the predictions that the model has been able to generate. As you can see here, this is the data set. This is the original dependent variable wherein the first person has preferred Clinton. Now, what is the value for Clinton? It says 3. Have a look at the predicted value. So the actual category is 3. The predicted category is also 3, which means that the first person has been correctly identified as a Clinton supporter. The second category is a misclassification because the model has classified him as 1. This is clearly a misclassification because this guy is a Clinton supporter. However, the model has wrongly predicted him as 1. When we look at some of the other cases, you can see the predicted value is consistently 3. This is what the confusion matrix also told us. When it comes to identifying Clinton supporters, our model is doing quite well. Our accuracy is 85%. Let me scroll down to look at some of the other candidates. Have a look at this particular case. This is case number 112. Let me scroll to the right side. The actual category is 1. The predicted category is also 1, which is a right classification. 113 represents a misclassification because the actual category is 2. The predicted category is 3. 114 category is a misclassification because the actual category is 1 and the predicted category is 3. Looks like there are a lot of Bush supporters as well as Perot supporters who have been misclassified as Clinton supporters, which is quite bad on the part of the model. You can see here there are 3 different columns that SPSS has generated. This represents the probability of group membership for each of the 3 candidates. This variable represents the predicted probability for the first candidate. The next column represents the predicted probability for the second column, and the last column represents the predicted probability for the third column. With this, I have come to the end of today's video. In today's video, we have seen how to carry out exploratory data analysis. We have seen the interpretation of a clustered bar chart, cross-tabulation, as well as Pearson's chi-square test. We went on to build a multivariate analysis model, namely CHAID algorithm. We have seen the interpretation of the decision tree model. Further, we went on to look at the risk statistic as well as the confusion metrics. Last but not the least, we have been able to generate the predicted value for each and every column. My apologies, for each and every respondent along with the predicted probabilities. With this, I have come to the end of today's video. I thank you very much for watching this particular video. I request you to subscribe to my channel, also like and share my videos. Thank you very much once again. Have a great day ahead.